Good afternoon, Namaste. A very warm welcome to all participants joining us for session 5 of TTDD 2026 titled Priority Verticals and Transformative Use Cases in 6G. I am Chandrakanta Rathod, the session coordinator for today's session, and it is my pleasure to welcome you all. Before we begin, I would like to share a few important housekeeping announcements. All attendees will be kept on mute throughout the session by default. Kindly post your questions in Q&A tab of the conference tool. This will be taken up during the Q&A session. Questions in the chat box will not be entertained. If you want to enlarge the presentation, please click on the expanding arrow icon at the top right of the presentation screen. The tool is configured for HD video. You may switch to LD in case you are facing bandwidth problems. Attendees may like to visit the exhibit booth of TSDSI in between the sessions to know more about our work. Attendees can use the lounge facility for networking. The lounge will remain open till the end of the conference. The conference sessions are being recorded and will be posted to the TTTD website in the next few days. Now, I would like to introduce our session convener, Mr. Vijay Madan. Uh, Mr. Vijay Madan is currently associated with TSTSI as advisor and mentor with special focus on standardization in services and solutions relating to evolving technologies and applications, vertical sector use cases, security and crypto, IoT, drone services, cloud computing, PPDR, future ICT enabling systems, also with JWG's focus connected with 1MTM, 3GPP, and ITUT. Welcome, sir. Now, I would like to hand over the floor to Mr. Madan to introduce the session co-chairs.
Thank you, Chandrakanta, and welcome all the chairs, distinguished speakers, and distinguished audience to this session on priority verticals and transformative use cases in 6G. It's my pleasure to introduce to you the eminent co-chairs. Mr. Sandeep Sharma is technology leader and AI innovator with over 2 decades of experience in 5G, ORAN, AI-powered networks, and emerging 6G technologies. As Vice President and Global Head of Emerging Technologies, Network Services Tech Mahindra, he leads global initiatives that integrate artificial intelligence with next-generation connectivity to transform digital networks. Of course, and the use cases and applications driven with it. He's well connected also with Bharat 6G Alliance, and I know him well from that side also. Second co-chair is Rupa C, and she is a senior telecom engineer and researcher at the Center for Development of Telematics, the premier R&D arm of India Department of Telecom, DOT. Everybody knows CDOT. She serves as an elected working group chair at Telecom Standards Development Society in India, and she has been there for the last 4 years at the working groups. Now I hand over to Sandeep and Rupa for taking it forward. Thank you very much.
Thank you, Vijay sir. Thank you, TSDSI, for enabling this session. A wonderful topic. So good afternoon, everyone. On behalf of TSDSI, it's my pleasure to welcome you all to this session on priority verticals and transformative use cases in 6G. I think use cases is something that it's important as we evolve into any technology dimension, but with 6G is getting more and more relevant. Normally, when we talk about 6G, the discussion is often starts with technology, higher data rates, lower latency, AI native networks, sensing, and whatever you say. While these capabilities are undoubtedly important, the real question is even much bigger. What problems should 6G solve and how it can improve the life of people, businesses, and societies? As India moves towards a vision of evolved nation, 6G presents a unique opportunity for all of us, not just to build the next generation communication networks or technologies, but to create a unified digital foundation for sectors such as agriculture, healthcare, education, manufacturing, transportation, and maybe smart infrastructure as well. However, achieving this vision requires more than technological innovations. It requires open standards, it requires interoperability, it requires trusted AI, secure data sharing, and most importantly, a common service platform that allows diverse sectors to innovate over a shared foundation while addressing their unique requirements. The choices we make today regarding priority use cases, platform architectures, AI integration, and global standards will determine where 6G will become another generation of connectivity or the digital infrastructure that powers India's growth for decades to come. Today's session has therefore been designed to address these requirements in multiple parts. Our keynote speakers will first share their perspectives on these dimensions. These perspectives will then set the stage for our esteemed panelists for the panel discussion, where experts from government, industry, healthcare, agriculture, startup, and technology will discuss how we can translate this vision into practical priorities, standards, and collaborative action. With this, it's now my pleasure to invite my co-chair, Ms. Rupa, to take us through the keynote sessions and introduce us to the distinguished keynote speakers. Rupa ma'am, the floor is yours.
Thank you, sir. Thank you, TSDSI, and thank you, Madanji. Good afternoon, all. Welcome to session 5. This program consists of 3 keynotes of 20 minutes each, followed by a panel discussion of 45 minutes, as Sandeep sir told right now. So the keynotes are first keynote is by on emerging India priority verticals that will define the 60 era and beyond by Sri Anil Bharadwaj, DOT, DDG. Second keynote is from networks to platforms, a unified 60 service delivery architecture for vertical ecosystems by Sri Mayank Gupta, Mahindra AI. And third keynote is digital twins, data governance, security, privacy, sovereign AI, and agentic AI for vertical ecosystems by Arvind Pandey, Sri Arvind Pandey, TCTS. And the panel discussion is about 45 minutes, and there would be finally concluding remarks by Sandeep Sharma. And then with 60 standardization progressing through use cases, architecture, requirements, specifications, promising a highly capable intelligence and data everywhere network, its worth and usefulness will be based on the services and applications it offers. What a developing nation will look forward and its priorities will be the positive societal impact, advancements, and solutions technologies can bring in. In this context, let us listen to experts from government, indigenous industrial and R&D bodies. What are those priority verticals enabling ecosystems, considerations, and governance? So the first keynote is by DOT, Sri Anil Bharadwaj. Ma'am, can you please present his bio, please? So Sri Anil Bharadwaj is Deputy Director General Strategic Engagements at the Department of Telecommunication, Government of India. And one moment, please. He leads strategic engagement initiatives, telecom policy development, and programs promoting indigenous telecom manufacturing and emerging telecom technologies. Anil sir, floor is yours. Please switch on your, turn on your camera, and the next 20 minutes you may please present.
Yeah, thank you, Rupaji. I hope I am audible.
Yes,
I hope I am audible.
sir, you are audible.
I don't know. Now I think I
Start, sir.
should be visible also now. No, it got off.
Uh,
I
yes,
am.
sir.
Am I visible now?
Yes, sir.
First of all, thank you, Sandeep ji, for that apt introduction for the session. And talking about. So should I continue? Am I audible? Because I
Sir, you are
heard yes
audible.
sir twice. So first of all, thank you very much, Sandeep ji, for that introduction, and my sincere thanks to TSDSI and the team who have put up this 3 days tech deep dive. India actually needs these kind of cohorts to discuss, take stocks, and analyze where we are and where we need to go. Uh, my I will limit my discussion to the priority verticals and where are we in terms of the focus of government. It says so. Is can somebody change the slide for me, or I need to do that? Chandrakanta Rathore,
On the screen, sir.
can
Next
you
slide is
can
on
you
the
change
screen.
the?
So I'm on slide number 2, agenda.
Sir, this slides are visible to you, Anilji? It is on the screen being run by Chandrakanta. Chandrakanta, Anilji has left the stage, maybe some issue. I request chairs to wait for 30 seconds and then when he comes back, then he can continue. Meanwhile, you can hand over to the other speaker. If 30 seconds or 1 month he doesn't turn up.
Did you lose me in between? I'm not sure.
Yeah, he's back. He's back. Yeah. Sir, we are
So,
on slide of agenda by you.
so I think I was explaining the slide two. Basically, we will talk about where we are and what we need to do to 2020. So let's move on to the next slide, ma'am. See, why are we talking about 6G? Uh, we are aware that many of the tech leaders have already started test deployments of 6G, and with the 3GPP release 21 and ITUR IMT 2030 and WRC 2027 already lined up, lot of in terms of freezing of spectrum, freezing of specification, and almost alignment of what are the kind of technology which are going to make 2.6G is almost there now, and we are looking at March 2028. Release 21 will be stage be frozen, and we will know what are the kind of technologies, what are the kind of things which will become part of 6G experience. And that is why it is an apt time to talk about this and look at what we need to do, in take stock of the current situation and look at what we need to do. We have the new act and new rules already available. Test and pilot spectrums are being made available on demand. We from government side feel that we have sufficiently eased the process, and any organization which is into research can actually look at spectrum, get spectrum. Second is that we have at least in two places, that is IIT Hyderabad as well as IIT Madras, that full test bed available where technology components can be tested. The public network is available there for the testing, and add to that 100 5G labs which we had DOT had launched. The launch was by Honorable Prime Minister in 2024. All those labs are functioning as on today, and they are enabling researchers to experience the 5G network and enable their testing if they want to test certain technologies. Of course, certain more equipment is required for the test purpose, for pilot testing and for the testing of components, and that is where DOT is focusing right now. that how do we provide that add-on equipment, because certain labs are seeking those requirements. Can you change the slides, man? So the framework Bharat 6G vision statement, I have already spoken about it. India was one of the key nations which launched a mission with Bharat 6G Alliance, an industry alliance which is purely run by the industry and academia, basically by the industry, and has been functioning. Uh, and it is being overseen at the highest level, sometimes not to the, even fully critically analyzed, sometimes not to the pleasure of some of the industry members, that we at DOT at the highest level, Honorable Minister himself takes stock of the situation, seeks assigned targets assigned by industry themselves. And in addition, Bharat 6G Alliance has already signed up collaborative agreements with 12 different 6G alliances of different countries. And during Bharat 6G Symposium, which was held during India Mobile Congress in October 2025, uh, Bharat 6G Alliance, along with total nine alliances, eight other alliances, came out with a Delhi declaration which talked about working together to achieve affordability, sustainability, and ubiquity, that is connectivity for all. And that itself is enabling cooperation with United Kingdom, cooperation with Canadian agencies, cooperation with Japanese and Korean agencies, which Bharat 6G Alliance is trying to grow to the next level. The institutional structure of Bharat 6G Alliance is, it works through the Apex Council, which Honorable Minister himself chairs. Then Bharat 6G Alliance has 7 working groups, each on spectrum, devices, core technology, application, sustainability, outreach. Ma'am, can you change the slide? Outreach, as well as on the use cases. The Apex Council is meeting on quarterly basis, and not only Apex Council, but Honorable Minister of State himself takes stock and is holding every 4 to 6 weeks, is holding a review meeting with the Bharat 6G Alliance team under the leadership of Chairman Professor David Kollapillai and co-chairman Dr. Kumar, and other team members including Sandeep is in the Apex Council. So the whole structure is purposed with a regular analysis of what we have been doing, where we are, and how can we assign targets for the next 1 quarter and next 2 quarters, and how can we contribute more to the standards process. Now going to the topic of this session, which is the priority verticals and transformative use cases. Can we shift to the next slide, ma'am? So these are the priority verticals which 3GPP and ITU IMT group have finalized, and they actually encompass, all the components of technology, which are the building blocks. So AI and ML, we are not talking of generative AI anymore. We are talking of networks which are intelligent enough, which can provide compute as well as connectivity on demand, which can provide capacity on demand. And that is the ask and task which has been, that how intelligence can be embedded in the network architecture, how networks themselves become intelligent and become self-healing and self-supporting. Uh, Integrated sensing and communication remains the second vertical. Non-terrestrial network, that is, 5G already started working with the satellite, and we have seen some of the launches where some part of the spectrum of 100 megahertz is being used by some operator to provide back-end satellite connectivity in unconnected area. But 6G looks at ubiquitous connectivity, that you are not going out of the network at all, and satellite connectivity becomes an important integrated part of 6G technology. On the physical side, it is the waveforms, the higher capacity of MIMO and radio layer engineering. And on the broadband part, fixed wireless access has been an integral use cases of 5G and 5G Advanced. In 6G, that goes to the next layer where the vision is that you do not need to lay fiber anymore for the local, reach to the house or to the pit, and you are able to provide last mile access through the radio access of fixed wireless connectivity. uh, Open RAN has been had been an important part and integral part. uh, in 5G also, ORAN network uh, was conceived, but it has still not materialized the way uh, it was planned and the way it was proposed. So 6G actually talks of disaggregated radio access network, and uh, a network which is really open, and in which different actors or different service providers can coexist and create a common network seamlessly. Then another important vertical is layer 1, layer 2, layer 3 software protocol stack. I'll discuss in details about that. And finally, not last but not the least, IoT has to become an integral part of the network. So, and very soon, India, the way IoT and M2M communication is increasing, very soon the main use cases and the main user base is going to be IoT and machine to machine communication, leaving voice telephony and individual connectivity, sim-based connectivity for you and me, individual users, far behind, uh, especially in the areas of where chatbots will start talking to each other. Your and my agentic AI will take over, and those agents will start interacting with each other and start using the network in a seamless manner, where compute and intelligence is sought not by us but by these bots, which will act as our agents and will start fulfilling our task. That's of course the vision. uh, so I think I have got a time message. I'll move quickly. So can we move to the next slide? So basically, India has already started contributing to different verticals. For example, AI ML, AI for 6G architecture, IIT Bombay has contributed. Geo platforms had contributed for quite a few things. Some of the information is very recent, and when we look at Geo's latest strategy document, they have contributed close to 200 patents in radio technology and in networks for AI. So we are certain that there are more and more cases will come out from Geo. Satish is here. He would perhaps know much better than me that how many contributions are there from Geo platforms. Then integrated sensing and communication, CVIT has contributed. Data framework, again CVIT has contributed. YSIG, IIT Hyderabad has been contributing. Uh, of late, they are not sharing information, but in 3GPP radio group, they are one of the very active players, and they are contributing. Similarly, IIT Kanpur is aligning with some of the uh, vendors and contributing. So this is the status of our India's contribution. Can we move to the next slide, ma'am? So of India has already contributed to IMT 2030, where link distance, rural configuration input for larger inter-site distance. 5G R gave us a space, and we are expanding it further with contributions like this, where we are talking of larger link distance and larger coverage. And for rural area, we have already made submission on peak spectral efficiency. And similarly, Bharat 6G Technology Working Group has tracked different spectrum bands, including 600 megahertz, 6 gigahertz, and 7.1 to 8.4 gigahertz. In fact, DOT's uh, the spectrum planning handbook, which has been released, the talks about making all the spectrum available for 6G by 2028. Uh, Initially in upper 6G, it is already made available, but 7 gigahertz also we are trying to make the spectrum available through, sorry, through getting the spectrum freed by existing use. And there are parallel studies happening from satellite use cases, that how the technology can co-work and the spectrum can be made available for the 6G pilot testing, and in future for the 6G network. So I'll request you to switch to slides, because I don't think I'm working good on time. Can we move on? So from a use case point of view, India, government of India is running quite a few applications to make use of the connectivity which today's 5G networks are providing. In fact, I'm happy to share today itself at the global WCIS platform, our initiative for rural connectivity and rural CSCs has been recognized by ITU World Summit on Information Technology in Action Line 6 for enabling, providing enabling environment through our Samriddh Gram Yojana, where we are putting up commercially viable use deployment of use cases at one rural facilitation center. And this whole arrangement DOT has piloted to achieve commercial success. See, putting something with the subsidy and not making it successful in the long run, not being viable, has not helped. And that is where the initiative under Samriddh Gram, which DOT has taken, and it is already functioning at 4 pilot places, has been now globally recognized by ITU under WCIS. So similar kind of use cases under e-Sanjeevani, e-agriculture, through the Drone Didi initiatives, through our manufacturing initiative is already there under PLI, and government funded use cases uh, through 100 5G lab, and we are now looking at taking it further under our TDIP scheme. How can we award the labs who are performing well to get more equipment, and make sure that uh, the students and researchers benefit from this availability. So my slides, I'll request them to share the slides. Madam, can we move to the next slide? So there are quite a few Indian companies which are very, very active. This is the information which is available. And as I said, Geo Platforms has been very active in filing some of the uh, patents recently. So they are not actively engaged in 3GPP in terms of contributions, but I am sure that the way Tejas, CVIT, IIT Bombay and others are contributing, India is going to have a very important uh, part in 6G standards. And while we have been talking of higher percentages of contribution, but I am sure we will achieve much more than what we as India ecosystem achieved in 5G and through 5GR. Our industry is more than ready and is contributing in different verticals. And we are certain that even if we may not get standard essential patents, but we will get sufficient number of contributions where our manufacturers tomorrow will be in a better position to negotiate uh, by sharing our standards, our SCPs with the global majors, and uh, be able to produce at much lesser cost. That's where I would want to end, because I think I'm looking at one or two messages. Thank you very much for providing this
Thank you, sir.
opportunity. I will leave it back to Rupa. Thank you.
Thank you, sir. Thank you, sir, on the optimistic note on 6G. And in your talk, you focused mainly on the government initiatives for 6G and how the government is enabling test beds and labs and introduction on Bharat 6G vision and cooperation with other countries and contribution overall to global standardization bodies. Thank you so much, sir. Now we will just see any question is there posted for you. I'm not seeing any questions. So thank you, sir.
Don't worry, I'll be logged in. If there are questions, we can take at the end of the session.
Thank you, sir. Thank you. So now we'll move on to keynote 2. From networks to platforms, a unified 6G service delivery architecture for vertical ecosystems by Sri Mayank Gupta, Mahindra AI. So Sri Mayank is a senior technical expert AI products at Mahindra and Mahindra, where he leads enterprise AI strategy and delivery across manufacturing and supply chain operations. Over the course of his career, he has worked with Hilti and Honda across India and the wider APAC region, building expertise in operations, quality, and digital transformation. He is an alumnus of IIM Ahmedabad and IIT Roorkee. So over to you, Mayankji. You can talk in next 20 minutes and question answer audience can post in the Q&A tab on the right hand side bar. Over to you, sir.
Good afternoon, everyone. Thank you, TSDSI, for providing me this opportunity and interact with you all. And I'm really happy to see all the good work that government is doing in this particular space, as was presented by the last respected speaker. So I think what I will be doing, I will be trying to do justice to the title that is highlighted on the slide that you see right now. The slide promises you an architecture, a unified 6G service delivery architecture for vertical ecosystems. Now I'm going to keep that promise, but I'm going to keep it in a slightly unusual way. I'm not going to draw you an architecture and defend it. I am going to earn it bottoms up from the use cases that will actually pay for it. Right. So because here is my confession, I do not build networks. In fact, I do not have any idea how do you guys build networks. I run factories. I lead AI products across Mahindra's automotive, farm equipment, aerospace, and defense businesses, which makes me a slightly rare person in the room today. I'm the customer, right? And for the next 20 minutes, the customer would like to talk. So can you come to the next slide, please? Three things about where I stand, so you know what lens I'm looking through. First, all this discussion is not theoretical to me. We run computer vision quality systems, agentic AI, digital twins, industrial data ops in production today on real factory floors on today's networks. So I know precisely where these networks help us and precisely where they hurt us. Second, this is, I think, the most important one over here, that we from industry buy outcomes. We do not buy networks. In more than a decade working across Honda, Hilti's, Asia Pacific operations, and now Mahindra, I have never seen a plant budget approved against megahertz spectrum or generations. Budgets are approved against scrap, uptime, throughput, cost per unit. And this is the only currency that a factory head recognizes. And the third, that inverts my question. Almost everyone in this conference is asking, what can 6G do? I am asking the opposite. What must the network deliver? As a consumable platform for a factory, a farm, or a fleet of operation, for a fleet of logistics fleet to build on it. That inversion is my entire talk today, and everything here that I'll present is will be sort of to justify the same statement that I've just now made. Next slide, please. Let me try to sort of make my point and come to that point that why does this inversion matter? Right. So I have, in my experience, seen genuinely excellent private 5G proposal come to our plants, strong radio design, honest coverage numbers, and capable partners. It died in a 40-minute budget meeting because nobody in the room could map a single line of it to scrap, OE, or number of vehicles or the cost per vehicle that we are getting. Right? The network was good, the pitch was fluent, but it was fluent in the wrong language. Now look at the two columns that I have on the slide today. On the left, it shows how networks are engineered: coverage, spectrum, throughput generation, release cycles, sold as connectivity contracts, right? Now on the right hand side, this is how verticals procure it, right? Verticals procure it on the basis of use cases. They are looking at how much scrap I would avoid, how much uptime I would get, how much yield I would be able to improve, how much cross changeover time I would be able to sort of access, right? Now KPIs which are owned by the plant head are not 3GPP release, and I promise you they never will be that, right? The KPIs that are owned by the plant head are the KPIs on the right hand side of the column, right? The second column. Now both columns are legitimate, but between them sits a gap, and this gap is what I try to cover by this term called a platform, right? And that is why I'm saying that is why we're able to do the justice to this title of this discussion, from networks to platforms, right? Now, until network capability is converted into a platform where the consumers like myself can consume it like my developers consume cloud instances today, it will never become mainstream, right? It will only be uh, ones who are signing the checks, right? CTOs are not the ones who are signing the checks uh, for the networks or any tech that we try to integrate into the processes, right? Next slide, please. So this is one and only architectural slide, if you want to call it an architectural slide, that I would like to put in this particular presentation. Now, when I say a platform, I mean 4 capabilities I would consume tomorrow morning, if somebody exposed them as a service to me, right? Now, 1, slicing as a self-service API. My manufacturing execution systems, especially the ones that are critical for driving productivity and quality on the shop floors, request deterministic performance on the line, the shift and the quality gates, right? So we cannot have any kind of a lacuna over there, right? And I want my developers to be able to consume these networks for those specialized services as they consume cloud instances, right? It should not be a 6-month operator-led project with a steering committee and a memorandum of understanding. Number 2, positioning as a service, centimeter grade indoor and outdoor continuous for every tool, vehicle, and pallet of material, exposed to my applications in the way a map API would be exposed to an app developer. Number 3, trusted data exchange, cross-company telemetry sharing with policy provenance and revocation built into the network layer, not bolted onto the contracts afterwards, right? And then AI native operations. Now, my definition of AI native operations is a bit beyond the network itself, right? I think a network being able to understand a problem, predict the problem before it happens, and be able to heal itself is one thing. The other criticality that we would also like to comment the network is that the network intelligence should not lie into the dashboard of the network operator, but it should also come to my application, right? So if there's a robotic fleet, that should not go to zone 3 because there is a prediction of a network dip over there. It should not, it should come to my application, and it should so happen, right? Now, building on this architecture, if you have to now come to the proving ground, right, how the factories of future or how the factories of today are, I think this is what I want to highlight in my next slide. If you can just move the slide, please. Now, this is the proving ground, right? So a modern manufacturing automotive plant today runs more than 20,000 connected sensors and devices. It generates terabytes of vision, telemetry, and test data every single day. And the business now expects the plants to reconfigure a line for a new variant because the market requires it in days. So if I have to come up with a new variant or a new model every 1 year, it is very hard to keep up our capacities with respect to the change and the new models that the market are developing. And that is why our lines have to be more and more adaptive, where we can onboard a new model every time there is a change in the market demand or every time a company is launching a new model. Now, every transformation program where we are trying to adapt the lines to a new model hits the network constraints, right? So if there is a vision quality, autonomous material flow, digital twins, agentic AI, whatever you name it, everything that we have built for a line hits the same 3 walls: mobility, determinism, and data movement. Today, we solve all the 3 problems in the same way with wires, and wires are precisely the reasons the factories cannot adapt. Right? Now, what I will try to do is that I will try to bring in now 4 use cases, 2 from manufacturing, 1 from supply chain, and 1 from farms, where we will try to see that how these problems inhibit the scale or adaptation on our shop floors or various areas, various functions. And then how can 6G as a platform help us if the architecture is made in a way uh, which is easily accessible, or it can be easily used by the people on the shop floor. Right? Next slide, please. Now, the use case 1, which I have titled Perception at Scale, I would like to talk about the vision-based quality inspection systems, right? So anytime you go to a shop floor today and you ask them what is the AI that you are doing on your shop floors, they will say that we have a vision AI model deployed over here, which tests the entire vehicle in and out and all that jazz. But I am someone who is at the other side of the table, who is responsible for developing and deploying these vision AI systems on our shop floors, right? And I can tell you one thing with a lot of authority, that the development we have done was never constrained by the models. The models are highly commoditized. The constraints was always the moving frames. Today, every camera is wired to a fixed station. Adding one inspection point is a civil work plus IT project, right? Trenching, conduit, switches, change requests. Plant Wi-Fi saturates the moment you put high resolution multi-camera uplink to it, and it drops frames exactly when the line speeds up. I have seen lines which are running at a 16 strokes per minute line, right? So essentially there is a panel being produced every 4 seconds, and we are expecting a camera to be able to inference, see that, take a picture, stitch the picture together across the entire, say, the roof panel of a vehicle, and be able to inference and vision AI model and be able to give the results so that we can stop the press line, right? And this is exactly where the network breaks, and that is why a lot of digital twins essentially becomes a mirror, but they are hardly usable in the uh, in the real world scenarios, right? Now, if there was a platform approach to a network, what would change, right? So there would be a massive reliable uplink, means hundreds of cameras streaming to shared edge inference. So perception follows the process, not the cabling. So if I have to change my layout, I'm just following the process of the new vehicle and not constrained by how I have laid down my network switches and cables. Inspection points get redeployed in hours, not in days. And the capability that excites me the most is integrated sensing. Right? So the radio layer itself becomes a core sensor for presence and motion. So the network does not just carry perception, it contributes to it. Now, one more layer, because this is where the economics will play out in a cost intensive manufacturing market like India. An isolated inspection point generates alerts that nobody trusts. Every operator would like to get some more insight into the anomaly that an AI model generates, and that comes from context, right? So for every anomaly, there is a very dense context that has to go with it, right? What was the shift that was being that the anomaly came in? Who was the operator? What was the process? What was the model that I was making? And this context is what crowds the network, and this is where the complexity starts to come in, right? I'll come to use case 2, and I'll just quickly cover these use cases looking at the time um, message that I just got. The second one is untethered economy, right? So untethered autonomy. Now this is where the autonomous mobile robots, right? So I think, to cut the chase short, what I'm essentially saying is that if we are able to make the network more deterministic, we can actually make our AMRs and robots much cheaper, right? Because the networks are not deterministic, and I cannot live with that, we have all the compute, all the intelligence lying on that robotic layer itself, which makes it much more costlier, right? So if you are able to take that intelligence, that compute, that determinism that we are building into the hardware of the robot out into the network, then the robots would become essentially cheaper, and my business cases would become much more better. And the smart factory, the robot would just be a smart peripheral for a smart factory, a cheaper peripheral for a smart factory, rather than become making an important part in making the business case in itself, right? And this can all just be enabled by uh, providing me deterministic networks which I can consume using a platform, right? The next one, the next slide, please. The next one I would like to talk about are transparent supply chains, right? So if in your cold chains, uh, today telemetry dies between facilities, right? Plant, carrier, port, dealers, 4 organizations, 4 network, 4 silos in a cold chain. We discover temperature excursion on arrival when the loss has already happened. This is detection, this is not prevention, right? So on a platform, the picture changes the scope. What I would imagine is that a network slice that would follow the shipment across the public network, across the public networks, the quality of the service travels with the goods, not the operator boundary, right? Now we are able to track our asset using an integration of probably terrestrial and non-terrestrial networks together, and the trusted data exchange we can get, right? And we are not dependent upon exchanging CSV files, and etc. Right? The next one, I think this is the most, next slide please. The next one is the most interesting use case that I see, which is the precision agriculture at Indian scale. Right? Now this is the same autonomous robots problem. The intelligence, the storage is still on our telemetry devices on our tractors, right? And uh, the reality is that in a country like ours, where more than say 70-80% of the Indian farmers are holding less than 2 hectares of land, uh, the 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 architectures that were made to serve the West, where the farmlands are in hectares, thousands of acres, it would not work up, right? So the data already exists with us, but because our tractors and implements generate it every hour they run, the value dies in transit, right? The soil and uh, what do you call the soil and implement telemetry stays on the machine, and it that advisory could have, which could have changed the sowing decision, that comes too late, right? Now with an integration of 6G with non-terrestrial networks, this is a problem that can be solved very effectively. And in fact, this is a strategic point. If we design 6G for smaller holder economics like MSMEs in India or smaller farm owners, we have not just made a domestic compromise. We would have built an export grade architecture, and most of the farmlands in the world are the farmlands that mimic what is happening in India, right? Not in Iowa. There's a very few countries where you will see thousands of acres of farmlands. Most of the countries are working on farmlands which are comparable to what we are doing in India, right? Now, next slide, please. If I have to sum it all up through the 4 use cases, I think there are 6 capability families, the same ones which I could see in the sessions abstract as well: reliability and latency, positioning, massive uplink, and IoT, slicing through APIs, trusting data sharing, and non-terrestrial coverage. Now, please do not read the whole table. Look at one column, slicing via APIs. It is the only column that is critical or important in every single row. Latency matters sometimes, positioning matters sometimes, the platform matters always. And that is the entire keynote in one gesture. The common thread across every priority vertical is not a radio capability, it is the capabilities getting exposed to consumable services as consumable services rather than buried inside the network as features. Next slide. So, like any operations leader, I would like to end it with 3 asks. One is, from this particular room, when you're designing the network architectures or platforms, put verticals inside the working groups from day one. The second would be standardizing the APIs, not just the radio. And the third one be design for India scale at default, not the down market variant. I think if you can just go to my last slide, I will leave the room with one sentence I started from. Verticals do not buy networks, they buy outcomes. 6G becomes a platform on the day a factory, a farm, a fleet can consume it the way developers consume the cloud. And that is the architecture worth unifying. And I feel this is the room that will sort of help us build that architecture and leverage it better in Indian context. So I'll close over here. Thank you. I hope I was on time.
Thank you, Mayankji. Thank you for your interesting, thought-provoking, and enlightening talk on expectations of a technology consumer, translating network capabilities into consumable services, and pain points one is experiencing presently. It was really thought-provoking. Let us see any question answer is there. Question is there for, I'm not seeing any questions. Is it? I'm not seeing any question. Okay, there is a question. What sort of networks are being used today?
In what sector, right? So because every sector is using different kinds of networks, I think shop floor networks are different, which are quite rudimentary, I still believe. I think we have now, uh, in the recent past, we have also experimented with private 5G networks in our shop floors. In fact, Sandeep was working very closely with us to enable those things in our shop floors. I think it would vary from use case to use case, and from sector vertical to vertical, what kind of networks are quite broad.
Thank you. Uh, we'll now move on to the next keynote 3. Uh, Digital twin, data governance, privacy, security, agentic AI, and sovereign AI for vertical ecosystems by Sri Arvind Pandey, TCTS.
Thank you. Thank
Sir,
you.
one moment, sir. Arvind Pandey is a technology and business transformation leader with over 40 years of experience in telecommunications, ICT, and digital infrastructure. He currently heads the Transformation Management Organization at Tata Communications Transformation Services, leading initiatives in digital transformation, automation, network modernization, mergers and acquisition, and AI-driven operations. Sir, over to you.
Thank you, Rupa, for the quick introduction. Uh, so I think the two earlier speakers were quite amazing in terms of one of the theme line which I'm going to take it forward is to see how technology can be enabler to generate the use cases, and that's with data governance using multiple technologies which 6G is offered in terms of digital twin, agentic AI, and giving a seamless platform and fueling up the use cases which is required. So definitely, as our speaker said, that there is a gap between what technology offers and what typically the industry would need, and that is where there is a synergy and collaboration which is required to see how some of those disruptive POCs can be done to see and adopt those technology in terms of generating the use cases. While technology is enabler, but what is most important is that it is not the KPIs or KQIs. It is definitely the outcome, which is what is required to see how you can fill up and deep dive technology. What is more relevant in this scenario for the India perspective that we generate volumes, we generate the use cases which is not there elsewhere in the world. The good news is that we have now taken a leapfrog approach in terms of the 6G development and the standards, where we see clearly that we could articulate some of the use cases, create a universal platform using digital twin, and create multiple use cases is what I'm going to talk about. So, if you can have the next slide, please. Yeah. So broadly, if you see, while my focus is in this talk is to see how you can create a USPs in terms of use cases. But what is most important is typically, as we see in telecom, that sometime early more advantage becomes a inhibitor in terms of giving the use cases. In the telco environment, there are multiple layers of the network, which is now becoming a deterrent to generate a monolithic network and leverage the 6G and some of the use cases which is required. Therefore, what we essentially we need to see what is the architectural shift which we essentially need to adopt to see and leverage and bridge the gap between the user requirement and probably which was not possible can be made possible in terms of doing a collaborative approach in terms of telcos, US DSPs, and data center and using the agentic AI and stuff. So there is a clear shift in terms of the architectural, uh, which is what typically telco or the OEM have been following. Uh, then second part is definitely seeing the capability. So, for example, if there is a sensing technology, if there is a deterministic technology, how can we leverage to drive the specific use cases and give the value proposition in terms of the cost economics as well as some of the revenue enhancement, which typically will fuel up from a business perspective. And of course, there are some simple use cases we can take as a case study to see how we can evolve as we move forward to see it could be some of those fueling the startups and also taking initiative from the government, as some of our colleagues talked about. And finally, what is important is to see how can we create a landscape. I think our Tech Mahindra colleagues also talked about both, that how we can create a platform giving the multiple APIs, giving the data governance layer, and then opening up the 6G capability to multiple software operators to see developers to see how they can create LLMs and SLMs to see what AI backbone can be leveraged upon. And some of these segments are basically transport, logistics, and health. I had been involved in creating a 5G captive network in Tata Steel in some of those locations, difficult locations. And what we realized that there are multiple use cases which typically are being hijacked the moment by Wi-Fi and some of those narrowband. But the moment we start giving a 5G and 6G technology, the use cases, the landscape completely changes. So I think there around 36 locations Tata Steel has across the globe can definitely take care of all the logistics, and some of those IoT-led services is what I can talk about. And finally, how can you create an ecosystem wherein there are multiple conflicting requirements? One is the network side, other is the platform side, uh, third is the using the leveraging a tool like agentic AI and software developer community, and then finally a product management leading to uh, the what is required to the end customer to give a service. So I think this is what is required to create and bind, and then get into the multiple edge side to see how you can create a deterministic service rather than predictive, which is what typically has been a challenge at the moment. So these are the broad content I would be talking about. Yeah, so I think this is probably a very simplistic way of saying that what essentially we need to see how to create a network fabric. And good news is that 6G is kind of an umbrella which takes about all those trustworthy networks, systems, and then creating a network computing fabric, which essentially has the ability to create a cognitive network. Cognitive network would be more getting into the network side to see how we can create a autonomous network and offer from connectivity to the platform or the digital fabric, and offer the limitless connectivity, and that will offer essentially all the four layers to say all the use cases over a network with standard API to see what are the use cases can be done. The right side what is talks about to how to really create a horizontal layer to see how end of the day what is required is to have application which binds the requirement as well as the network side to create a series of connected system and offer those digital application or a network fabric basically. So essentially if we see, it is a AI infrastructure creating a network connectivity, and then third layer is the digital fabric, and fourth is the application layer, and fifth of course is the product and services which essentially the user would want to enjoy. So end of the day it is the user, product and services which is what is enabler, for which all the four layers are required to be kept alive, and then have a disruptive or a transformative approach to see how you can create a network which is enabler to offer the multiple services. So it is a push and pull. While the push will come from the user side to see this is what we need, the pull will be from the network side or from the product side or from the 6G side to say how can you be enabler to see what are the new services and product offerings you can create to offer to multiple use cases. So that's a broad typically theme of this enablement, which is a bit of strategic shift. If you see earlier, there used to be a software upgrade, update, and OEM used to rule entire thing. Then subsequently, multiple technology system integrators came and they started integrating the multiple uh, OEM and then giving a network side. And then it came how to create a monolithic network and uh, keep a hardware agnostics and create a software based network. So all these basically getting into a phase where you that there is a segmentation to leverage and create a monolithic horizontal based network and offer those use cases. So that's the broad thinking and theme which is going on across the globe, the telco. Next slide, please. Yeah, so this is typically coming from an OEM mindset. And if you can see that even now in India and actually in globe as well, that the FWP cases and enhanced mobile broadband is overruling. And what people are looking for is ultra reliability and low latency, which will have ability to fuel up the EMBB plus, and as well as some of the industry 5.0 use cases, which is typically is being now talked about with the 5G advance. But uniquely, what you get in 6G is a completely paradigm shift as compared to the broadband or a low latency. Here, what you are able to do is to combine the multiple blocks of the pyramid and give a multi-dimensional services, which is typically, if you can see the left side is the critical services, and omnipresent the 5G industry 5.0, leading to IoT services for the logistics, industrial sector, as well as the health sector as well. So that is where you see there's a paradigm shift in terms of fueling the use cases which is required to be done. Uh, Global broadband, of course, is the connectivity which is required to have the multiple roaming capability to offer multiple application use cases to with a low latency, of course. So that's a broad driving factor for the use cases. I will not go in detail in the interest of time, but this is kind of giving, which is what I talked about in terms of 6G is giving a platform enhancement, which typically was not there in the baseline of the 4G and 5G. And bit of that has been there in 5G advanced. But if you see, like I said, the sensing technology is a part of it. The native network, which is required to create a monolithic network, and high reliability, low latency is what is driving the use cases in high mobility scenarios. Now, that is where I think the 6G is a very a killer application to have a high mobility scenario where you have a capacity and coverage layer and offer a unique combination to see how you can create a reliability and low latency. That is where the the health services will take a good advantage in terms of doing the surgical operation, and see how across the globe we can leverage the multiple people, doctors, and some of those surgeons to see how you can people can the society can leverage those benefits across the globe. Positioning, like I said, it is very important. It's a very centimeter level 3D positioning, and thanks to digital twin, where you have 2D digital twin, you are able to simulate the network and simulate the application, and give essentially a overall on the real application to see how what is going to happen in terms of some of those network side to predict some of those application which eventually doesn't run even after the POC. Multi-sensor integration is one part where the native integration model is coming up to see what common architecture can get evolved. So these are some of those enhancement which is a paradigm shift. People do talk about that why 4G, why 5G, and why 6G is coming. So 6G is very niche application, and it is all centric around the use cases, which is what the theme of this this seminar is about. Now, this is what I sort of took it from some of those white papers to see what are the typical use cases driving technology side. So if you see, it used to be earlier AR, we are now be getting into the mixed reality, and there are multiple shared experiences. There are a lot of Verizon trials which they are working on, and there are some AT&T trials on the global internet side. Autonomous mobility is being talked about in Europe. Some of those telcos I'm purview to, and then critical services in terms of emergency services on the disaster recovery, using leveraging digital twin, and then create those simulate those emergency communication. Spectral data, exposing the data coordinates, and see how this can be leveraged to get into the data lake, data analyze, and then move on to multiple analytics services. Massive digital twin data collection, excuse me, which is what is a lot of network modeling is talked about in terms of creating the digital twin for the education services, the network services, the dark knock, and multiple network operating center, leveraging those digital twin to see create those predictive, not predictive but a realistic analysis, and of course, all this can be possible using the super awareness with agentic AI and bind those multiple process and create a unique workflow system which typically really helps to bind those multiple technology and give a application based services binding the multiple process application, which was a bottleneck earlier. Without the agentic AI, it was probably looking difficult. So this is a broad drivers technology segment, which is what is driving the use cases. Now, these are sample use cases I picked up from a broad perspective. Railways is one area, and I am preview to some of those trials which is happening in RDSO. They are talking about a paradigm shift because they have good fiber. They are now leveraging the edge data center which they are creating. If you have a fiber, you have a data center, and if you are able to create those captive network, lot of things can get into the predictive maintenance alerting, and there could be a multiple good transformation which is happening in across the globe. Public safety is one area. Logistics, like I talked about, it could be disrupting in tempering alerts. Container vehicle is one part where it is required for across globe. I know Sintel is talking about this, and they are integrating with a lot of satellite base, integrating with so that the containers is always connected is what the typical applications are. In the interest of time, I'll go to the next slide, not getting into the details. Uh, yeah, so these are, of course, very hardcore 6G, which is not possible. A lot of things are being talked about, which is not possible in 5G and 4G, but the potential is very high. Typically, on the electricity side, you can see that there are lots of data centers which are coming, and now government has given the EV and the grid system to the data center. So autonomous smart grid system is the need of the hour to give fuel all those data centers, and more importantly, it will go to the edge side as well. And other thing which is being talked about, the quantum mechanics, quantum physics, to generate those defense side, surgical side, and also on the multiple ultra high low latency application, which are mission critical application. The other thing which I wanted to talk about is the battery system, because even the car, even the multiple a lot of battery application is coming out to create a management platform and see how you can have a coordinated approach on the battery side. Last I already talked about the logistic IoT. This is going to be a killer application in terms of Industry 4.0 to see how a data center can combine those 6G technology, create a application platform, and then give multiple services. End of the day, it is integrated such the AI network and low latency is what will drive the multiple use cases. Finally, the last slide, which I would talk about how we can create that. What are the drivers which essentially we need to work on? How can you fuel the use cases? I think what is important is to have create a digital fabric and with multiple POC. While there are multiple platforms like Amara and other platforms, but we need to create such a ecosystem. I saw that there are a lot of things that are going on for the Reliance Jio, and the DOT is working on that. So this is a good news to see how we can fill up this with standardization so that the platform can be used for multiple agencies. And for sure, we need to have a common API. Like, for example, for the voice API, there is a 24 application which across the globe people are talking about. And I will not go in detail, but I'm working on that. There are common platform, 6G platform narratives which people are working on. Definitely, there is an industry and user collaboration. I think our Tech Mahindra colleague talked about, and evolve a business model. It is not important to have a technology. What is important is to have a revenue model or a use case or a benefit which we need to evolve business model. So there's a complete shift into the business model, and then definitely operational challenges to say how we can prioritize the sector. While we do that, I think the mission should be from local to global. Whatever use cases we do in across in India, definitely will find application, and that is where I think we should collaborate, work together to see how we can contribute. Lastly but not the least, it is the contribution, the revenue generation and market creation which will fuel up the use cases. And we all as the industry colleague need to work together to see how we can collaborate, create and leverage strengths from each other, and then see how the standard will help to create those use cases. Maybe it's POC, but definitely working on those use cases, which is what is required from our side. So that's what is from my side. Thank you so much for the patient hearing.
Arvind sir, in your talk, you mainly concentrated on paradigm shift towards 6G and use cases, user product service centric strategic shift from traditional OEM SI dominated terrains, multi-dimensional services, use cases driven by 6G integrated capabilities, emerging use cases like smart grid system, quantum security, IoT, etc., which are the need of the hour and which will benefit from 6G, key drivers of successful 6G and business challenges and revenue generation. Thank you, sir. Now let us look for any questions to you. Yes, 5G itself. Sir, in the interest of time, we'll take one question. Why quantum security platform require digital twin?
Okay, so digital twin is an enabler, and essentially what it does it because of the real-time application, which is what is the basic fundamental, and which is a deterministic in nature, would definitely need a real-time, low, ultra-high reliability, which is the basic need for quantum mechanics to derive those ultra-high latency as well as the digital twin to do the processing on real-time basis. So fundamentally, anything which is requires a real-time processing will need basic digital twin as well as the quantum technology. And to drive multiple processes and standards, you need to have agentic AI. So these are the three key drivers, which is what I have mentioned in my earlier slide: connectivity, this, and then enabling, which is all the three drivers, and then giving the product is what essentially the guiding and the pillars are there.
Thank you, sir. Sir, there are a few more questions which are directed to you. If possible, you can answer over the Q&A window, sir.
Sure.
Thank you, sir. So with this keynote segment is over. Now it is a panel discussion which is driven by Sandeep, sir. So over to you, Sandeep.
Thank you, Rupa ma'am. I think it's a wonderful discussion that we have in last 1 year. I think we heard about India's vision for 6G. We heard about the importance of platform-based architecture and the transformative role of AI. I think the panel that we are going into now, this panel is more about turning that vision into action. What we have to do to explore such sectors, which sectors basically which India should prioritize, and how standards can enable scalable, innovative, inclusive innovation. What we must do over the next few years to position India as a global leader for 6G enabled digital ecosystem. I think before we begin, I'd like to briefly introduce our distinguished panelists. So we have, we go to next slide. So we have Aditi Nanda. Aditi is from Intel. Aditi is the director for ecosystem and industry for APJ Intel, driving strategic collaborations that fuel innovation across sectors. With nearly 2 decades of experience in business leadership, marketing strategy, and ecosystem development, she spearheads industry alliances and market access programs, reinforcing Intel's role as a key enabler in India's startup ecosystem with a focus on AI-driven technologies. Aditi also serves as a lead for strategic initiatives across education in India, harnessing AI to transform learning landscapes. She is an IM Lucknow alumnus. Aditi is passionate about tech-driven innovations that reshapes India's future. Welcome, Aditi, to this panel. Next panelist, we have Shri Deven Singh Ji. He is a senior officer of the Indian Telecommunication Services of 1994 batch. With over 3 decades of experience in telecommunication policy, regulation, and standards-driven development, he holds a BTech from IIT Delhi and a postgraduate diploma in public policy and management from MDI Gurgaon. During his career, he has served in the Department of Telecommunications and organizations like MTNL, BSNL, TRI, and LSA, overseeing telecom licensing, service delivery, and regulatory compliances. He has also served on the deputation with the Ministry of Urban Development, External Affairs, and Home Affairs. Currently, as a Deputy Director, Journal as Telecommunication Engineering Center, he leads initiatives on AI standards, including frameworks for accessing fairness and robustness in AI system. Welcome, Devendra ji. Next panelist is Mr. Manoj Khanna. Manoj Khanna is a renowned expert in water and natural resources management and over 40 years of experience in research, innovation, policy. Founder and principal consultant at Hydro Sage Advisory. He previously served as a principal scientist at ICAR, Indian Agriculture Research Institute, until 2024. He holds an engineering degree from IIT Delhi and a PhD from University of Melbourne. His expertise includes precision in the irrigation, climate smart agriculture, groundwater management, drought monitoring, and AI and IoT enabled agriculture. Welcome, Dr. Khanna, on the panel. Next panelist is Ms. Preksha Shah. Preksha Shah is currently a senior research scientist at Freestream Technologies, working on global standardization efforts in TSDSI, ITUT, 3GPP, and ATSC. Prior to this, she was research scientist in IIT Bombay. Her interests include AI-driven network optimization, energy-efficient communications, spectrum-efficient broadcasting to everyone, typically B2X systems, convergence of broadcast and cellular networks. She has served as a co-chair of Workgroup 4 at the ITUT Focus Group on AI native for telecommunication network (FGAIN). She was also recognized among the 100 brilliant and inspiring women in 6G 2024 by Women in 6G. She received her PhD in MTech in Electronics and Communication Engineering from W Professional University, India. Welcome, Ms. Preksha, on the panel. Our next panelist is Shri Saroj Kant Mishra ji. Saroj Kant Mishra is a distinguished endocrine surgeon, educator, and digital health innovator, a medical graduate from MKCG Medical College, and a postgraduate in general surgery from Postgraduate Institute of Medical Education and Research. He founded and led the Department of Endocrine Surgery at Sanjay Gandhi Postgraduate Institute of Medical Sciences from 1989 to 21. He currently serves as Emeritus Professor at Kalinga Institute of Medical Sciences, a pioneer in telemedicine. He established the School of Telemedicine Biomedical Informatics as SGPGIMS, and he served as a consultant to ITU, WHO, UNOOSA, and World Bank. Welcome, Shri Mishra ji, on the panel. Great. So now starting our panel, I think I'll briefly structure the discussion in such a way that we get engaged across all the sectors. But before starting to sector specific comments of 6G, I like to uh, question a very broader question to all the panelists today. I think you can spend around 2 minutes each on while you give the response. The question is, as India moves towards next wave of technology leadership, which one or two 6G use cases do you believe should be India's top priority and why? And what difference will 6G make to that use case compared to what we have today? Let's start with Aditi.
Hi, Sandeep. Thank you so much for having me here. And good afternoon, everyone. It's been an interesting 1 hour. Got to hear a lot of different points of views and very enlightening. So very happy to be here and to share my thoughts on this. It's a very interesting question that you've posed, Sandeep. And I think not just as a case study or a use case, but I think as India moves towards the next wave of tech leadership, I believe 6G should be one of our top priorities. And the top priorities of 6G itself should be that we touch every citizen's life and every day. Of course, we've heard some of the esteemed guests today talk about, the promise of 6G and how that is going to be different. The whole terabit by per second speeds, the latency being really low in microseconds, and of course the AI in the fabric, which is going to be the game changer. If you ask me about the use case of one or two, and there was a gentleman who showed us a couple of use cases across manufacturing, across education, across agri, across healthcare, but I will dig into my own experiences and share something that's very close to me, and what that I think would be a great use case and would make a lot of difference. So while I was growing up, I grew up in different parts of the country because my father was in the army. And at one such time, my father was posted in a place called Akhnur, which is in JNK and which is very close to Uri, some of you might have heard of. So there were floods the year that we were there. And there was one bridge that connected the small town where the army base was with the rest of India or the rest of the mainland. And that bridge on Chenab River got washed away. You can imagine this is before the era of mobile phones. This is before, you had to trunk dial at that time. This is in the early, so a while ago. So you can imagine there was no connectivity. There was no way to reach the other side or the mainland and to be able to talk to or to talk about what is the disaster management, what is going to be the way forward, how do we sort for this. So I feel, Sandeep, 6G coming, one of the major game changers is going to be things like this, where you're looking at disaster management, where you're looking at giving connectivity across different regions, across different uh, different scenarios, where you're looking at giving connectivity in the remotest part of the country. So that is one of the use cases I think that will really proliferate. And I'll talk about AI in the whole fabric and the network fabric in a minute, and as we go along. But I'm excited for use cases that will be built on AI as well, especially in the education sector, especially in places where you have inference already running in the network. So those are also exciting. But I think giving connectivity and having high speed connectivity everywhere at every time and connecting these kind of situations, even in places of disaster management as well as remote connectivity, would be something that I would talk about, Sandeep.
Thanks, Aditi, for sharing both the personal experiences and the professional insights of what makes sense with 6G. Thanks for sharing the insights. Next, I'll move to Shri Devendra Singh ji. Your views about this question.
Good afternoon to all. Thank you, Sandeep ji, for posing these questions. As we know, there are a number of use cases for 6G, but if I have to identify one or two priority 6G use cases, then I would choose those that have a direct impact on human lives. The first is the intelligent healthcare. We all know India's vast and diverse geography presents a major challenge in delivering timely, high quality healthcare to every citizen, making digital health technologies increasingly important. An intelligent 6G network enabling continuous, reliable connectivity among variable health devices, ambulances, and hospitals can significantly improve healthcare delivery. A heart patient in a remote village could automatically trigger an alert to the nearest health center for immediate medical assistance. This will this will save both lives and resources. The second would be the precision agriculture. We all know the agriculture remains the backbone of our economy. AI, combined with 6G connected sensors, drones, and satellite data, can help farmers optimize irrigation, fertilizer use, pest management, and crop planning. This can improve productivity, reduce costs, and make farming more resilient to the climate change. So the second part of your question is what makes 6G different from today's network? The answer is, in addition to offering higher data rates, high reliability, and very low latency, 6G will introduce a few new capabilities. First is the AI native. It will integrate AI into every layer of the network to optimize operations. Second, the integrated sensing and communication capability. It will enable the network not only to communicate but also to sense and understand its environment for applications such as healthcare, transportation, and disaster management. And the third, the integration of terrestrial and non terrestrial networks, including satellites and high altitude platform stations. It is expected to provide seamless connectivity even in the remote and the underserved areas. These capabilities of 6G will transform the network from communication platform into an intelligent digital infrastructure. Thank you.
Thank you, Devendraji. Thanks. Now I think I'll turn to Shri Manojji. Your views about what are the 2-3 top use cases that should India prioritize?
Thank you, Sandeep and good afternoon to everybody. You have taken a very important topic. I think so. Mr. Devendra Singh also made my way very clear. I prefer two main cases. One is a smart agriculture with disaster resilience as a close second. And because they are not very glamorous, but they touch most of the Indians, solve problems so no other country can solve for us. Consider agriculture. Nearly half of our workforce depend on that, yet farming is still very reactive. We deploy, take the example, we in Smart Kheti, we are in a today's network, we are basically advising farmers to monitor soil moisture, automate irrigation, soil nutrient, and apply need-based fertilizer, and providing advisory. But today's connectivity caps it. Rural coverage is patchy, device density is limited, and intelligence sits far away from the road. So what is 6G going to make a difference? It's going to be a large coverage through non-terrestrial or satellite link network, finally reaching every village, massive device density, millions of sensors per square kilometer. It is possible using one gateway. We are covering large number of farmers in an area. AI built into the network. That's another icing on the cake itself. So decision happens on the edge in real time, and farming shifts from reactive to predictive. That's very important. And second priority, as I said, disaster management works on same platform: forest fire detection, flood alert, real-time loss estimation, and broadcasting this information to the authorities and citizens, even when ground network is not working. In a climate limited country or climate stress or water stress country, this resilience is a national security. That's very important. And the common thread is 6G fuses connectivity, sensing, AI into one fabric, and network stops being a pipe, becomes a sensor. So sensor-based technology is going to be the future, and 6G leads the way. Thank you.
Yeah. Thank you, Manojji. Yeah. Now, Preksha, your views around it from your lens. What are the top 2 use cases that make sense for India towards 6G?
Thank you, Sandeep. I feel that India should not choose between social impact use cases and commercial potential use cases. It should be able to balance between both. Therefore, public service inclusive connectivity should be a priority because 6G leadership is not only achieving peak data rates at urban scenarios, it is also connecting the unconnected. As Aditi mentioned, bridging the digital divide is important and should be focused on. Therefore, use cases such as remote education, smart agriculture, telemedicine, healthcare, emergency alerts, disaster management should be one of the priorities. Also, as India is a vast linguistic diverse country and it has identified more than 1300 mother tongues. Therefore, bridging linguistic divide is also important in order to have inclusive access to knowledge and services. Direct to mobile communication can help can help in realizing these use cases and delivering these services using broadcast infrastructure without entirely depending on the active internet connectivity and mobile data. Therefore, affordability can also be supported. Another use case should be AI-enabled, AI-native smart manufacturing, as also pointed by Anil Bhardwaj sir. In a way to escalate India from low cost manufacturers to high reliability, high productivity, high quality markets to enhance national economy, smart manufacturing should be a part of the priority. And Shiksha can help achieve this via IoT enabled low power devices, sensing, connected robotics, digital twins, early fault detection and analysis. This can reduce the delay in manufacturing and the downtime and also enhance the quality of the products. Thank you very much.
Thank you, Preksha. Quite diverse opinions. Thanks for sharing your views. Now, I'll request Shri Mishra ji to share his views about the two top priority 6G use cases for India and how it makes difference. Shri S.K. Mishra ji is online or?
Am I audible now?
Yeah, we can
Hello.
hear you. Yeah.
Yeah. So thank you, Sandeep ji, and good afternoon to all the panelists and eminent speakers. In fact, my opinion has been going to be a little repetitive what Mr. Devendra Singh and other panelists has also spoken. I just want to add only one word. I think that will make a lot of meaning. Health is a fragmented system. I think you all have realized. You meet two doctors, you'll have two opinions. And barring the situation that you all know, geographical conditions of our country, the so-called telemedicine has not been able to address issues in Northeast and other hill areas, and leave aside the seas and other inaccessible geographic locations. So here I find that in the 6, I have worked in 3G, 4G, and now 5G also. Now 6G will definitely enhance the limitations of 5G in 2 or 3 areas that I think about is the modeling, practicing procedures, and surgery can be more safer. So the surgeons can create digital twins, so can operate in immersive environment before going to the operation theater. That one of the area I can think about. Second thing is the remote monitoring situations like tele-ICU. You have already spoken about Internet of Things. I call it Internet of Medical Things. So here you have so many connected devices, sensors, patch. You can monitor even a pregnant high-risk mother. So those things are definitely going to be enhanced. But the issue is here, the problems of health is a state subject. So you have to have a standardized system to be applied all over the country. If you want the technology to really deliver the services in a proper way, that area needs to be addressed actually. Second issue is the competency development of the healthcare workers. Here also I find a lot of potential of 6G. I'll just give one or two examples. So now the tele-ICUs doesn't require a very experienced critical care specialist to be posted in the ICU. There are agentic, you talked about agents, so they can really help you out. Even a MD medicine doctor can really look after an ICU and take in the help of a remote experienced critical care specialist. You talked about machine to machine communications. Here I talk about machine to human being communication. That is very important. I'll give an example. In operation theater, you operate in critical situations. A surgeon may not be expert in everything, but there is the system there which can create an environment of assisting a surgeon by analyzing the real-time surgical videos using computer vision and machine learning technology, and assist the surgeon, alerting the surgeon that whether he's doing the right thing or wrong thing. They're all technologists who know about pattern recognition, so they exactly match from the library different stages of surgery. There are two things I highlight. One is the healthcare, where CG can play a role, and second thing is competency development of the doctors. So as you go along, I can talk about something more.
Sure. Thank you. Thank you, Mishra ji. although the panels is quite from a quite diverse background, but I see a consensus-driven response that okay, ubiquitous coverage and ubiquitous connectivity coupled by inclusiveness of the use cases is something that is needed in terms of all the use cases that makes for 6G success for India. Having said that, I think now we from generalization to more specific questions to each of these panelists so that we have a more, I would say, double click of the opinions, what different sectors of the industry think about 6G. I'll start with from the government sector, Shri Devendraji. Uh, from the perspective of, from a national perspective, AI will play a key role in achieving a nation or towards a world state. And AI is expected to become a key part of 6G. From the government perspective, how should India use AI to solve national challenges in areas like healthcare and agriculture, education, and disaster management? Also, what role should standards play in making these AI solutions trusted, secure, explainable, and available to everyone? Request of you, Shri.
Thank you, Sandeep. This is a very important question because 6G is not merely about faster wireless communication. It is about creating an intelligent digital infrastructure where AI becomes a native capability of the network itself. That is why it is impossible to discuss the future 6G without discussing artificial intelligence. While 5G connected devices, 6G will connect intelligence. It will enable people, machines, sensors, robots, and digital twins to work together intelligently in real time. For a country like India, the real success of AI will not be measured by the number of AI models we develop or the amount of compute capacity we create. It will be measured by how effectively AI improves the lives of 1.4 billion people. The government, therefore, has an opportunity to use AI not only as an innovation engine, but also as a powerful instrument for inclusive development. Let me briefly touch upon some of the important sectors which can be served by intelligent 6G networks. First, let us talk about the healthcare. India faces a shortage of specialists, especially in rural and remote areas. AI, supported by 6G connectivity, can significantly improve healthcare delivery. AI system can assist doctors in interpreting X-rays, CT scans, and pathology reports within seconds. Wearable health devices can continuously monitor patients and alert doctors before a medical emergency occurs. With ultra-low latency and extremely reliable communication expected in 6G, remote diagnosis and even advanced telesurgery will become far more practical than today. In addition, AI can help in disease surveillance by analyzing health records, environmental data, and mobility patterns to detect outbreaks much earlier. Hence, AI can shift healthcare from being reactive to predictive and preventive. And if we talk about agriculture, we know nearly half of the India's population still depends directly or indirectly on agriculture. AI combined with satellite imagery, drone data, IoT sensors, and weather information can help farmers make better decisions regarding irrigation, fertilizer use, and pest control. Instead of blanket recommendation, AI can provide field-specific and process-specific advices. Millions of sensors connected through future 6G network can make agriculture far more data-driven and climate resilient. This improves productivity while reducing input cost and environmental impact. AI can also strengthen supply chains by forecasting production, predicting market demand, and reducing post-harvest losses. And another important sector is education. India is one of the world's largest education systems, but ensuring high-quality learning for every student remains a challenge. AI can enable true personalized learning. Instead of one curriculum for everyone, AI tutors can adapt lessons according to each student's learning pace, strengths, and weaknesses. Students in remote villages could access the same quality of digital education as those in metropolitan cities. Real-time language translation powered by AI can even remove linguistic barriers and make education content available in all major Indian languages. And when we discuss about disaster management, we all know India is highly vulnerable to floods, cyclones, earthquakes, and heat waves. AI can analyze satellite imagery, weather data, river levels, seismic information, and social media feeds to generate much more accurate early warnings. During disasters, AI can optimize evacuation routes, coordinate emergency response teams, and improve allocation of relief resources. Resident 6G network combined with drones, autonomous robots, connected sensors can continue operating even under challenging conditions, improving both rescue operation and post-disaster recovery. However, while discussing the opportunities, we must also recognize an important reality. AI cannot simply be deployed because it is powerful. It must be deployed if it is trustworthy. People will only adopt AI system if they believe they are fair, reliable, secure, and accountable. That trust doesn't emerge automatically. It has to be built systematically, and standards are one of the most effective ways of doing so. Standards help ensure AI systems are not technically efficient, but also transparent, explainable, robust, and safe. They provide common methods for testing, evaluating, and assuring AI systems before they are deployed at scale. This becomes particularly important in sectors like healthcare, agriculture, and disaster management, where incorrect AI decisions may have significant consequences. Government has already recognized this need and working on development of standards for AI systems. Telecommunication Engineering Center, that is TEC under the Department of Telecommunication, is actively working on standards and assessment frameworks to support trustworthy AI deployment in telecommunication and beyond. TEC has already released a couple of standards in this regard. One standard is for fairness assessment and rating of artificial intelligence system, which provides detailed procedures to identify biases for assessing and rating artificial intelligence systems for fairness. This standard provides a systematic approach for certification by a three-step process involving bias risk assessment, threshold determination for matrices, and bias testing. The other standard is for schema and taxonomy of an AI incident database. This standard provides a comprehensive schema for an AI incident database, and the taxonomy systematically categorizes the documents AI incidents to improve understanding, prevention, and mitigation of AI-related harms. TEC is also finalizing one standard for robustness and assessment of rating of artificial intelligence system in telecommunication, network, and digital infrastructure. This standard provides framework for assessing and enhancing AI robustness, focusing on core principles like availability, confidentiality, integrity, etc., and the core elements like privacy, reliability, and safety, etc. At the end, I would like to conclude with one thought. If we focus only on developing advanced AI models, we may achieve technological progress. But if we combine AI with trusted standards, secure digital infrastructure, inclusive policies, and citizen-centric application, we can achieve something much bigger. That is, we can transform public service delivery itself. Thank you.
Thank you, Devendraji. And as you mentioned that agriculture is one of the sectors where AI can make a real difference as well, especially for millions of farmers. Let me now turn to our agriculture expert, Shri Manoj Khanna ji, to share his views. To Manoj ji, if you think of agriculture as a sector, help us understand
Yeah.
how can AI and 6G together help farmers improve productivity and income to make a tangible impact on their social life and economic life as well, and what common digital platforms or ecosystem is needed so these solutions can reach every farmer from the affordability perspective, including those in remote and rural areas. Over to you, Manoj.
Thank you. Thank you, Sandeep ji. It's very, very important. As Mr. Devendra Singh already mentioned, we are talking of the half the population of the country, and we are basically farmer-centric country. And as I told earlier, today's farming is a totally reactive. A farmer acts when the crop shows stress after the pest is spread or the rain falls. Yeah, this year is, you can take the example, monsoon is failing, El Nino is on our head. AI and 6G together put shift from reactive to predictive. What we are doing basically start with sensing. Look, solar powered soil sensors like we are implementing through Smart Kheti, read moisture, temperature, nutrient, weather data, crop health continuously across the field. And 6G adds these three things together, today's network, which cannot be. Coverage that reaches every villages through satellite, non-terrestrial link, density to support millions of sensors, and AI built into the network, so decision can happen at the edge in real time. I will give you a simple example. On weather base, a pest attack may happen. Immediately, a message should go to the drone that it should spray certain pesticide or herbicide or disease control so that the crop can be saved. AI turns this raw data into action. It predicts irrigation need before the soil dries, flags pest and disease risk early, and recommends the precise dose of water, fertilizer, pesticide, not more, not less. The productive gain is concrete: less water wasted, low input cost. We are getting higher yields, fewer crop failures. Farmer does more with less. More crop per drop is the best example. The productive gain is concrete, as I told you. Now, how you are going to lift the income? This productivity alone cannot guarantee income. This platform should connect farmers to the market. Real money comes from the market, not just to the sensors. AI-driven advice, what to sow, when to harvest, where to sell, uh, helps the farmer to capture better prices instead of selling into the glut. And many times you must have seen in the stories in the newspapers and TV. Direct farmer to government connectivity means all the subsidies, advisories, satellite-based advisory, insurance reach to the farmer without middlemen taking a problematic route for him. Real-time loss estimation via GIS means faster insurance, faster, fairer payout when disaster strikes. And the ecosystem itself creates rural livelihood. You have drone services persons. Drone Didi is one of the example. Sensor maintenance, self-employment of the village youth, income rises all across the community, not from the only one farmer or one farm. Common platform, what is reaching every farmer? Here is the important point. Point solution won't scale. 100 apps then don't talk to each other. Everyone is developing app and leave the remote farmer totally baffled. We need one interoperable ecosystem. Take the example, Mr. Devendra Singh talked about the standards. We are talking of one open standards. One M2M gives us interoperability. So sensors, gateway, servers from any vendor work together, integration with all the servers. Take the example of C. server, gives it national and sovereign. Second, universal reach. This is what 6G gives us the edge. Non-terrestrial satellite link coverage finally closed the rural connectivity gap. No farmer is excluded because where or he is living at a far place. Thirdly, a simple access layer interface must work with the farmer with a basic phone in a local language, and where at the government and GIS and policy level, same platform, we are talking to each other. Fourth, security. Again, Devendra Singh ji mentioned about that. Data security is very, very important. Data trust is there. Farmer data is in farmer asset. Platforms must protect and give the farmer confidence to participate. Unless he is ready to agree to share his information, we are not able to do it. Built this way, the platform becomes public infrastructure, like complete, like roads, electricity. Network becomes a more of a infrastructure thing. Any solution can plug into and every farmer can use. So what I am lead to say, AI and 6G together, something we never had. They fuse connectivity, sensing, intelligence into one fabric. Network stop being a pipe and become a partner in the field. And technology reaches everyone only through a common, open, sovereign platform and real nation by building. If we get this platform right, we just don't raise one farmer seed, we raise the productivity, income, and dignity of half of our India, rural India at that scale. This technology leadership is worth important, and we have to work on that. Thank you. Thank you, Sandeep ji.
Yeah, thank you, Manoj, for sharing your views about agriculture. I think just like agriculture, healthcare is also an important sector where technology can improve access and quality of services in life, especially in the remote areas. Let me now invite our health expert, Shri S.K. Mishra ji. Uh, so, Shri Mishra ji, I think the question for your inputs is 6G can enable remote diagnosis, as mentioned in previous discussion. Uh, Telesurgery and AI-assisted healthcare. While these technologies can improve healthcare access, how do we make sure that these are safe, trusted, and protect patients' privacy? Because explainability and trust is something that needs to be built in the technology itself from the day one. Who should be responsible if an AI system makes a wrong recommendation? And how we can bring more trustness or towards explainability in the outcomes that we recommend to the patient? Over to you, Mishra ji.
Thank you, Sandeep ji. You have raised this question to me also yesterday. So I have realized this. I do not need this question to be prompted. My experience in digital technologies in healthcare, starting with telemedicine, spans over 30 years. I started my telemedicine practice using POTS. You are all technologists too. You know the age-old telephone system, POTS. So I started that. Even I started monitoring ECGs for Kailas our pilgrims using POTS from Kalapani PSCs. So setting Lucknow. So I have gone through those technologies. And today 5G I'm practicing, right? Now 6G is in horizon. I'm not so excited. Let me tell you frankly. You talk about 6G, you talk about AI. Let me tell you very frankly to my colleagues who are technology experts, technology doesn't transform to medicine, let me tell you. To some extent, it can transform. Always remember, technology with human touch is very important. I ask this question to all of you. Will you accept any technology platform, advise you something without talking to your friends or colleagues or doctor friends? None of you will do that. So let's not live in a utopian region. In India, our healthcare we have to address ourselves. We cannot practice something happening in the USA. You see all kinds of practices happening in European countries, other areas. I'm very sorry, we cannot practice those things because, as you know, in our countries is very diverse. You practice something in Delhi or Bombay is not same as practicing something in Meghalaya. So we have to look the sentiments of the people. Dr. Sandeep ji, you know very well. The telemedicine practice guidelines, you raised me this question, standardizations of practice. Telemedicine practice guidelines developed when? In the 2020, when the COVID occurred. And as a emergency situation, we have been pleading with the government for 20 years. Because 1999, I remember I started telemedicine. 20 years it has gone by pleading to the government, everybody. And I was also working with the Minister of Health, with Minister of IT also. So no, none of them really hard everything. No, 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 it's okay, fine. Practice. When some problem occurs, we'll see that. But when COVID occurred, then the telemedicine practice guidelines, so-called TPG, was introduced. And let me tell you, it is not a bill. It's not even accepted in the cabinet. It is not a law. It is just an annex to the normal practice by the doctors. So today, till now, also telemedicine not been kind of accepted as a formal form of delivery of telecare. And today we are talking of machine learning and we're talking of machine delivered advices. Your question is that if a telemedicine platform gives you the advice, will you accept that? No, I said no. You must have heard many of these press reports that what do you call AI will make the pathologist, dermatologist, all those few specialists obsolete. Can you imagine that? Can you believe that even another 100 years, our Indian colleagues, our Indian citizens will accept this thing? Sorry, we may be whatever technology enthusiast, accept technology is fine, but when you come to the touching human life, be careful. So to answer to your question is that you are responsible. If you are accepting advice from AI doctor, then you are responsible, not the businessman or a corporate who has introduced these things. Let me put it that way. You might have heard a news item in China. There is totally AI hospital. There is no human being there. China is extreme, right? I don't want to go in details about that. So we have to touch the base in our system with technology as a facilitator. We should not replace our practice with technologies. The most important thing that we have to do is we have to develop guidelines. Today, your DPD Act or the Digital Data Protection Act was introduced only recently, right? After 3 years of debate. When was the GDPR was approved in Europe? Long ago. We have a HIPAA guidelines for healthcare data. When was it introduced in India? So all these things we are much behind schedule. Now to talk of the AI getting all this utility of AI in terms of data analysis, predictive medicine, all those things, blah blah blah. Let me tell you one thing. No two hospitals share the data. Am I right? You go to another hospital, you have to repeat your CT scan. You go to another doctor, he'll write another prescription. Same medicine, different name. So unfortunately, that's why I said that we are diverse, we are completely fragmented healthcare system. Even in US, every state had their law. You cannot practice from California or going practice in New York. No, you cannot. So it's a very difficult area. You can make drone DD, so many things. I can read the newspapers. That you can do it. You can operate a machine, spray fertilizers, but you cannot play with the health of a person. Imagine yourself patient, your own relatives, your own family members. I'm sorry. I will not accept. I will not plead anybody. I will not. I'm very much technology enthusiast. I'm very much technology positive person for that. Not otherwise, for 30 years, I'm not working in this area. I go to different countries. I to WHO consultant. Let me tell you, there are gratifying results of doing telemedicine in North Korea. North Korea, you may not have seen also. You might have heard very funny things about North Korea. Let me tell you, you deploy telemedicine. I'm so happy. 5 times I've gone to the North Korea WHO consultant, taking all difficulties. I'm so happy because I could really help them making their healthcare consultations from a special hospital to a remote area. Today, I'm working with Timor-Leste. This is a new country developed 20 years ago from Indonesia. I'm so happy. There I'm using satellites. Then satellite, I've never even heard about, though you have ISRO, I've been working with ISRO for last so many years, from 2003, but we never had internet from satellite because of security reasons, I've been told. So today, when you use a satellite-based internet, then I'm so happy that telemedicine can reach out to Timor-Leste, to remote hospitals. Extreme situation, extreme hill areas that exist in our country's northeast. So we should look at those things. Let us not get kind of biased with AI. And let me tell you, AI is not a same 6G. You can still practice AI without 6G. Am I right? You're a technologist. I want to interpret a radiological investigation. So my radiologist get a help from AI without a 6G. So let me clarify that point. 6G is not always required to practice AI. And AI is very much helpful in radiologist to get a diagnosis when I'm confusion, because doctors are not all God. They also have deficiencies. That's why I mentioned in my previous talk that you have to standardize the training, education of the healthcare workers, doctors, paramedical workers, nurses, everybody. We have to make them skillful. Can you make a uniform standard for entire country? Yes, you can do that. Now comes the utility of AI and 6G is the immersive learning you have been talking about. All of you have talked about digital twin. Let me tell you, I am going to operate a liver tumor. I have just have a CT scan preoperatively. But when you operate a patient, open the abdomen, the same liver tumor what you see in CT scan is not same as what we saw in the abdomen. So I have to superimpose the intraoperative image with the preoperative image. The same digital twin I created, as you all said, personalized modeling, you can make it. So here make a personalized modeling, then I know exactly where the big vessels lying behind the tumor. How should we be careful about that? There comes the agentic AI that you're talking about. Here it is a surgical assist that happens inside the theater. I'm using a edge computing infrastructure inside the theater, not in the cloud. So those are the utilities, and for that you have developed guidelines. Your question is specifically on guidelines, ethics. We have to develop guidelines. We are far behind for that.
Understood. Thank you, Mishraji. I think your point is valid. Wherever we are touching human lives, there has to be laws, regulations, access of data, sharing of data is needed before implementing any fully AI use cases. But I think the way I look at the industry, initial use cases will be where doctors and humans will be in loop while taking AI decisions. And 6G we keep as a technology which will make AI uh, accessible to a larger population at the right amount of time at the right speed rather than having a isolated access of AI. So more democratization of AI will happen when 6G comes in. That's how industry is looking at. Now we have a great inputs about both agriculture and healthcare, and there's a common need of trusted AI and reliable connectivity and for a digital secure platform as well. These cannot happen without the right technology foundation. Now I'll take Aditi's help. Aditi's from Intel. She can help us with her views about. So question to you, Aditi, is
Mhm.
When many experts believe that future 6G services should run on a one common digital platform with a shared AI layer or maybe standards API, how important is this approach, and how can open standards help reduce cost, improve interoperability, and speed up the innovation, for sure, keeping the guidelines in mind? Over to you, Aditi.
Thanks, Sandeep. And this is a very passionate panel, I must say. So, hearing my fellow panelists talk about different use cases in agriculture, on health and education, I think Sir was just talking about immersive education. So, it's very heartening to hear all of this. So, like you rightly said, Sandeep, the future 6G services running on one common digital platform with a shared AI layer and standard APIs, just hearing this panel today is not going to be a nice to have, but this is going to be what is going to be essential if India wants to have an affordable, interoperable, and truly inclusive 6G. Because I think that's what most of the panelists, and you helped summarize it very well. I think those are the angles that we are looking at to come in from 6G. Now, when you talk about, how does this work, or creating a national 6G AI platform, essentially, and how do you keep it open in terms of open APIs but standardized? Something that we should look at, and something that India has already done and has led the way with, is UPI for payments. And again, going back into anecdotes, and because that's how I remember stuff, when UPI started, I don't remember last time when I went to an ATM to take out hard cash, right? So that's how ubiquitous UPI has become. And when UPI really started, people were arguing about how every bank should build its own proprietary payment app. I think one of the panelists also spoke about how in agriculture, having different apps, leads to confusion. I come to that in a minute. But from a UPI perspective, by having, or by choosing, India chose a shared platform with open standards. We created something so powerful that it has really brought everybody onto the payments platform. Digital payments being accepted across the country ubiquitously. So, a common 6G AI platform, and I've just heard Mishra sir as well on medicine and on agri. So those kind of things would happen, could do the same thing. A 6G AI platform could do the same thing with that UPI did for payments, similarly for telemedicine or agri advisories, or even online learning for that matter. And that's how I'm looking at it. But what happens because of the standard APIs, and I know Preksha is also here, she can talk about how it is very important for startups and for people to be able to plug in into standards as well as open APIs so that folks can create uh, solutions. And of course, the AI layer on top of it means that it's not only helping the data sets like for agriculture or for telemedicine, but it's also using AI for the network when it comes to self-healing networks or congestion management or security, energy efficiency. All of this is going to be India's opportunity, and putting a shared AI layer on top of the network is what is going to make it different. So, I'll talk about the other thing, which is the national reference model, which I think, one of the panelists was mentioning when it came to agriculture. So, Manoj sir was mentioning that, I think, in a minute, some time ago. So, those kind of things where you have a database across. So, I used to work with Cropin in one of my previous roles, and Cropin does agriculture technology using apps, and that had such localized data that, and we were just talking about fragmented farming is fragmented, and how farmers, and sometimes the boundaries do not look at boundaries of state, how we draw it on a map, right? A farm can go across states. So we've seen this happen. because you're on one side, it's picking data from, say, Karnataka, and it's giving you some sort of inputs. And when you move to the other side of the farm, because it's in Tamil Nadu, it's giving you another set of inputs, right? So those kind of things, when you have a single data layer, a single AI reference layer, those kind of things go out of the picture. And that utopian picture that Dr. Mishra sir kind of just painted, where you're looking at telemedicine and and maybe in Korea and other parts of the world already happening, where you're doing remote operations. To get to all of that also needs one very, very robust layer of AI inference that is built in the system and that's built on the network. So I think that is the way that we are looking at it, and that is the way we should be looking at it, Sandeep. And that's how, if we are able to bring in, it'll reduce, of course, interoperability will help build a whole network of machines, devices, apps, all working across operators, all working across borders, lowering the costs by integration, one integration, many deployments. Capex becomes lower. Startups become, it's easier for them to start up and put solutions in the market very fast and easy to go to market. And of course, trust and safety comes into the whole picture as well, when you're handling, specifically when you're handling sensitive data. So those are the things that I think will make a change. And if we keep 6G open, shared, and AI enabled, I'm sure with all the solutions that we have spoken about, all the use cases we have spoken about, we can make sure no Indian is left offline and no Indian idea is left locked in. So that is how I'm looking at the whole architecture piece, Sandeep.
Thank you, Aditi. Thanks for sharing views of considering the diversity of India, and at the same time considering how the unified layer will help in achieving innovations much earlier. So now, I think we heard about the importance of common platforms, AI, and Aditi mentioned about the open standards, openness is 6G. But technology creates value only when innovative solutions reach the market in time. That's where startups play an important role. Let me now turn to Preksha from the startup perspective. So, Preksha, question to you is: startups brings new ideas very quickly, and what support do startups need from industry, government, and the standards body to build innovative solutions around 6G that can not only come to market at right time but also scale quickly, not only in India but globally as well? Over to you, Preksha.
Thank you. Startups basically need three kinds of support, that is access, standardization support, and early market creation. So access here means access to real infrastructure to help better create products uh, and help analyze the performance and validate the products better as compared to demo lab. So experimental setup, access to experimental setups, anonymized network data sets, rural test beds, satellite test environments can be very helpful. Also, startups need standardization support in terms of participation in standards such as 3GPP, TSDSI, ITU, ORAN, and the support can be in terms of fundings, mentoring, expert mentoring, test and certification, and patent filing. Also, from industry and government, a very important support that startup needs is a paid pilot program where startups can test and deploy their solutions. So, for example, a startup working on rural connectivity can get support of access to real test beds and early procurement opportunities. Because support with grants is one thing, but deployment opportunity is really important for a product to scale. Thank you.
Thank you, Preksha. I think very rightly to the point response what startups need. I think we all are from industry and government here today. I think we hear you. I think we'll try to extend support whichever way it is possible. But very nicely put. I think early access is something which is needed for the startups at right point of time so that they can test and validate things. And mentoring is something to guide which things make sense for a longer vision to scale. I think thanks all the panelists. I think we discussed national priorities, sector-specific challenges, and technological needs, and especially need for from the startup perspective as well. Now, I would like to conclude with one final questions for everyone. Let it be very quick. If you could recommend, the question is, if you could recommend just one thing that India should do in the next 5 years to become a global leader in 6G, what would it be? This time, I'll start with Preksha. You first.
Thank you, Sandeep, for a vision of India to become a leader. Important is to India to build a national 6G lab focused on India-specific use cases. Therefore, a 5 years vision should be developing and running large-scale 6G pilot programs, including rural connectivity, agriculture, smart agriculture, D2M, disaster management, AI native network orchestration. So all these pilot programs also should have a clear output in terms of a standard contribution, a patent, an open API, a tested product, a deployable service model. Therefore, the vision of for India to become a global leader should include all these. Thank you.
Thank you, Preksha. Um, now, question to you, Mishra ji. What one thing that India should do?
I would recommend a connected health system across all the verticals, whether it is public health care or it is emergency health care or it is training and skill development in the national policy development. That is one. Second thing is identify areas which requires real 6G. There are many areas which doesn't require 6G. You can use it 5G, even 4G also you can do it. So because bandwidth is very expensive and very costly, they're assets. So you have to optimize the utilization of bandwidth. I think that should be policy directive.
Thank you. Manojji, your views?
Sandeep ji, my recommendation would be build a national open 6C sovereign platform, make it public like infrastructure, roads, electricity. We should not, our scientists normally focus on patents, chase a spectrum, build a platform. Every solution can plug into and every citizen can be reached. And automatically, once the platform is right, everything else will follow. Startup build up on it, farmers, responders, citizen use it. Standards flow will real deployment, not theory. Leadership becomes a byproduct of solving our own problems at a scale. So one thing in the end, don't be build 6G product first, build a platform first, then let the large population, we have more than 1 billion population, build on it. That will be a wonderful thing in the coming next 5 years. Thank you.
Hi, thank you. Thank you, Manojji. Devendraji, your views?
Sandeep, I don't think there can be a single thing which can make India a global leader in 6G. But if I had to recommend the most important thing, it would be to strengthen India's journey from research to global standards. Universities, startup industry, and research institutions must work together to develop AI native 6G technologies, validate them through test beds, protect them through patents, and actively contribute them to organizations such as 3GPP and ITU. By consistently translating research into standards, India can become not only a leader in 6G, but also build a strong innovation ecosystem, strengthen domestic manufacturing, and create long-term economic growth. Thank you.
Thank you, Devendraji. And finally, Aditi, your views about what one thing that India should prioritize?
Honestly, Sandeep, if we can do whatever my panelist friends have said, we are there. So I had nothing more to add. I just wish we can do whatever everybody has spoken about, and we will be the power leading 6G across the world.
Thank you. Thanks, Aditi, and thanks to all the panelists for being a wonderful panelist, sharing views passionately and openly. I think overall session was done in very energetic way. We have very diverse opinions coming right from Anilji, talking about the government's view, what progress we have done. Then we have Mayank's view about platforms, the importance of platforms, and sharing his experiences from manufacturing world. And then Tandanji talking about uh, uh, what industry has learned so far from 5G and what we should take care in 6G. And if I summarize overall the panel summary and the summary from the keynotes, one, two, three things are very clearly coming out. One is like India needs something which is ubiquitous, which is connecting a large population, large agriculture, large societies. So ubiquitous connectivity is going to be much more important for all of us. At the same time, we should be looking not only implementing technology, we should also be equally looking at what adjacencies are needed to be addressed before implementing those technology. For example, if we need to align data systems, if we need to align policies, if we need to create new guidelines, we should be looking those guidelines much in advance rather than waiting for the technology to arrive. Thirdly, startups play an important role. So we as an industry should also play an important role collectivity to enable those startup ecosystems, because those guys are the one who are actually touching the waters much earlier than most of the industry that may be thinking of. Having said that, I would like to conclude this session with thanking all of you, all the panelists, all the keynote speakers, for sharing valuable insights, quite diverse opinions, but we synergized on many things. We'll share our learnings of this panel in the final event, and looking forward to stay connected with all of you and exchange notes on the very transformative transformative phase of 6G, where AI is being included but is not accepted in full sense till now, because we need to bring lot many explainability and other things. But we are on the way, or on a path that many things will happen in parallel, and we have to act on those things collectively well in time to take the advantage of technology much ahead in the curve. That's all from my side. Over to you, Chandkanta.
Thank you, sir. So before we conclude today's session, I request all the speakers and panelists to kindly turn on your cameras so that we would like to take a group photograph of yours.
Are we
Thank
done?
you. Yes.
Thank you. Thanks, everyone.
Thank you, Sandeep ji, conducting
Thank
very
you,
efficiently.
Thank you all.
Thank you, Rupa ji.
Thank you. Thank you,
Thank you,
everybody.
everyone.
Okay. So now I would like to thank everyone and thank all participants to share their valuable feedbacks on the today's session, and your feedback is extremely important for us. So kindly scan the QR code and provide your feedback to us. We sincerely appreciate you taking a few moments to share your thoughts, and we warmly invite you to join us for the next session, the next insightful session of TTDD 2026, titled Open and Interoperable Systems for Seamless Connectivity of Heterogeneous Networks. We'll start at 4:30 p.m. IST today. Have a wonderful conference experience, and we look forward to your continued participation. Thank you.